Smokey from Bera just beautifully explained how liquidity can become modular, and they have a very similar design when it comes to how operators can participate in a network and stakers can participate delegating to operators. So maybe we can kickstart with kind of just going into where applications are today. I think we're really focused on liquidity at the protocol layer. We're really focused on making sure that modular stacks are easy to build, but at the same time, a lot of the support that has come for protocols and AVSs, these actively validated services building on EigenLayer, it's not necessarily the same as the amount of support that the application layer has. And so we really want to, again, everybody's focused on modularity right now, but that goes beyond just, what tech stack you're using, what DA layer you're using, etc. I think it really focuses on how do you enable people to expand on the rate of innovation of Ethereum. And at EigenLayer, we're really focused on how do we increase the coordination acceleration of Ethereum. So, you have applications today which are like crypto applications, mainly in DeFi, and we have cloud applications in Web 2 that we eventually want to be able to port over. But today we have, crypto brings native incentives, it brings user governance, permissionless innovation, right? These are all attributes of having liquidity on chain. These are all attributes of being able to delegate that liquidity to operators who will now participate in new services, earning yield on behalf of you, and pass it back. But sorry, could we go back? No, all good. Whereas cloud applications don't necessarily have to worry about a lot of these things. Like cloud developers don't think about block space. Cloud developers don't think about gas optimization. Cloud devs just assume that things are going to scale. And liquidity, quite frankly, isn't a factor unless you're, funding. So when it comes to how do we, port over these applications, there's really a framework that we use, which is like value per bit. How much value is in these applications, right? At a per transaction layer, how much is in each bit? And so you see these like really high value applications in crypto today because people see a value to the economic security backing all of this, right? Which is why EigenLayer right now has 8 billion TVL to kind of back all these new services that are building on top of us. But on the flip side, these lower value per bit projects we're starting to see pop up in the ecosystem, right? Where there's not necessarily, we might not necessarily see value in why all of the moves in a chess game between me and a player might be valuable, but in the law of large numbers, an on-chain gaming platform could be very valuable, right? And so EigenLayer's real focus is like, how do we enable that liquidity that's on our platform to be validating for all these additional services and building on top of Ethereum. So going into rollups, why liquidity, right? We're seeing a lot of liquidity-based rollups today. We're seeing, Blast, New Paradigm, etc. We see plenty of different protocols trying to take approaches at this, but at the end of the day, rollups are the perfect fit for consumer apps, and so we need to be able to support them in our ecosystem. And so, we can think about it from the perspective of like, yesterday on one of our panels, Rishi from Movement asked this question about why isn't Facebook building an L1? Right. And, we can go down the rabbit hole of them having tried with DM and, all of the nitty gritties around that. But the reality is there is nothing to stop a project like Facebook, which already has a bunch of users, a massive network effect to be able to deploy on a platform other than, what is the value of decentralization? And so, what we see with consumer applications is that there's not necessarily as much of a demand for as much decentralization. I think the real focus sometimes comes from how do we bootstrap a user base on day one? How do we bring liquidity onto the platform on day one? And then the real focus is like, as Smokey mentioned earlier, how do we build this like strong network effect? How do we build this ecosystem that's capable of driving value to all of the participants? And so you end up with this overall platform that's able to drive value to all of the actors in the ecosystem. But there are complexities around this with how some of this liquidity can be thought of. A decent mental model, I know I'm totally going off slide right now, but a decent mental model is, and very much still in design. One that we're talking about is like cat bonds, catastrophe bonds, if you guys are familiar. And there's this whole spawn of liquid restaking tokens that have come up on EigenLayer, which is representative of the restaking yield that they'll potentially earn. And I was actually chatting with Chinda about this, but, cat bonds specify systemic risk for like, natural disasters in the world, right? And so you could almost assume that like these ABS positions or these operator positions have the same like specified localized systemic risk to like a local cat bond, whereas a cat bond fund might be similar to an LRT token, where they're taking a hedge across a bunch of different risks and taking a stance on which ABSs might be going through compliance or being able to drive yield back to these users. And so, there's some features of these rollups that can provide really good value propositions to applications, but the reality is the incentives aren't necessarily aligned properly. We see a lot of airdrop farming. We see a lot of like temporary activity, but then not necessarily long-term moats that projects can build on. And so this is something that plagues the entire ABS ecosystem in Eigen, and they're actively trying to build strong partnerships. But how do we make sure that these projects are capable of maintaining a certain amount of liquidity as well as sustainable incentives to their ecosystem rather than just driving them in with a bunch of potential yield off an airdrop and then these, builders or these users go away within a couple of months? Just next slide, please. Thank you. Amazing. So there are some problems today, and we're taking a stab at some of these problems across a few different points. And the real point here today is going to be around security for liquidity, but I'll briefly touch on throughput and some of the other stuff. Like I said earlier, crypto devs worry about block space. Block space is an inherent, a design pattern of how we like optimize our applications, but we really want to enable a future where devs don't think about block space, right? What are the applications that people could build if this wasn't a limit? We had a interesting example yesterday of someone say like they wanted to build an on-chain tax auditing platform, right? We had, which is just like crazy. But if everything was, yeah, but if a project wants to go out and build something like that, there's definitely like, cloud space auto scales versus block space doesn't. And so there's some limitations inherently in terms of design patterns. And that's something that we want to break up. But then really going into the cost economics of like how people are building today. Steph, thank you. No, you're good. We could go one more real quick. Amazing. Thank you. Yeah. So rollups today are not competitive with L1s, right? DA cost is high. DA cost is extremely uncertain. They have to take exchange rate risk, and there's not necessarily a utility value to the rollup token, especially if you're running a centralized sequencer sometimes, because then there's no decentralization either. And so the rollup sequencer is responsible for ordering, responsible for consensus. It gets sent to a DA layer, which is often ETH L1, extremely expensive. And then now you have a project that, isn't necessarily aligned with Ethereum, but is trying to bring Ethereum users on board, is trying to drive value to its rollup. And so with Eigen, and, it says Eigen DA, but Eigen DA without EigenLayer is like not nearly as powerful. Eigen DA is just a data layer service, right? There's plenty of other alt DAs. We have some like technical abilities that like help us separate, help us scale. But the reality is what really makes EigenLayer and EigenDA a superpower is, there's been this joke around Ethereum alignment, but how do you actually drive value alignment is completely different, right? Regardless of which ecosystem that you want to be aligned to, there's a certain amount of value accrual that comes from these applications building that needs to be driven back to the right sets of stakers and operators. That's what really alignment means. And we see that Berachain is trying to do something with their L1, driving value to their stakers, their operators. And similarly, our focus is to drive that value back to Ethereum stakers and Ethereum operators. And so by, reducing all of these things, but mainly enabling this dual token staking model or multi-quorum staking model, we can now enable these ABSs, actively validated services, or enable these rollups to be able to pay for DA fees in their own token. So not only are they able to leverage the liquidity from EigenLayer, which is restaked onto EigenDA, so the economic security of the DA layer, but rather they can also pay for those DA fees in their own token. So now you have effectively a second quorum. You can have token holders as well as operators now store that data for you. And drive that value and pay it back to Ethereum stakers, Ethereum operators, or you get aggregate security where you have this additional quorum from your own rollup and you're able to drive value to your stakers and operators as well. Because, in order for data to be made available, there needs to be certification across both quorums. Now, in a worst case scenario, this also helps you when it comes to, hey, EigenDA was down for some reason, or my stakers and operators on my rollup are colluding because my token price is dumping. You're no longer worried about the security of your rollup because you're leveraging the security that's on EigenLayer instead. This kind of just goes over what I just said, but like I said, EigenDA isn't nearly as powerful without EigenLayer, and so the ETH staking, the decentralization of the operator set who's actually storing and holding your data, in addition to for the actively validated services, actually validating your service and being an active participant in the operator network. These are all ways where we can drive good token exposure and ensure high DA availability for these rollups. And the end game is to enable these rollups to no longer be limited by their virtual machine or be limited by their, as I mentioned earlier, block space, because we want to be able to support these alt VMs entering the landscape, right? Movement, ZKVMs, WASMs, etc. These are all going to dramatically reduce the developer footprint to get onboarded. And that's kind of the main focus here. How do we enable, whatever liquidity is on EigenLayer to participate in the acceleration of Ethereum requires us to reduce the barriers of developer entrance into the ecosystem. I think, there's about 20,000 Solidity devs today with about 20 million devs worldwide, right? So how do we make a dent in increasing this developer network and as a result be able to build all these new services? We can go straight into the next one. And here's a rough idea of some of these services that we want to enable this liquidity to transfer over to. So not only can people restake on Eigen, but they can delegate that stake to an operator that participates in specific services, and those services will generate yield and drive them back to the operator as a staker network. But there's a plethora of different things that we want to actively innovate on in the ecosystem. And so, whether that's trusted execution environments or, proof of identity for someone like WorldCoin that's already working on something like that and wants to integrate with perhaps a bridge partner, or, if you want to do, what would it be like if you wanted to run OpenAI on chain, right? What's the bandwidth required to build something like that? In addition to, how do you make sure there's a certain level of authentication between each step on that LLM? And you want to be able to pause the LLM at a specific layer and be able to modify it and things like that. So these are all different problems in the ecosystem that, aren't necessarily things that we're ready to solve, but the infrastructure more often than not precedes the use cases. There's very rarely instances where the infrastructure has to adapt to the use case. But we saw this in Web 2 with cloud, and we're seeing it again, where Web 2 cloud dramatically reduced the footprint for developers to onboard and build. And in Web 3, that goes beyond the developers, but also to liquidity mainly. And where is this economic security coming from in addition to the validation services and the actual, building of this new software that's trying to, expand the scope of what we're focusing on here. So just to summarize, shared security is just strictly better, right? We've seen multiple different implementations of this across various ecosystems. Proof of liquidity is one example. Cosmos has tried, multiple versions of shared security. Polkadot has had its own variant. AVAX had subnets for a bit, but the reality is, all right. But the reality is, the shared security enables these services to borrow from these stakers and operators, and rather than $1 billion allocated to a bunch of different services, we can have very, very specific granularity about how much economic security is backing each individual service on EigenLayer, And so there's a high degree of freedom for both the staker and the operator to participate at like an individual layer on each project potentially. And the reality is, we don't necessarily know how much security each protocol is going to need. A bridge protocol is going to need dramatically different security than a trusted execution environment compared to a watchtower network, for example. And so as we, continue to unpause the caps, continue to increase the amount of TVL and liquidity on EigenLayer, the real question is, how do we, as we said, auto-scale that security to projects that need it? And we're hoping that the market will regulate itself to some extent in terms of demand of these services. But the reality is, a new bridge protocol on day one might need a lot more allocated to their service than a new watchtower on day one. And so that's just kind of the fact of the matter. Eventually, and this is, much later in our roadmap, but we want to introduce Eigen Insurance as a method of utilizing some of this liquidity to be able to, essentially protect assets. Mainly, the first use case is in transit. So rather than assets in bridging can be, you can buy insurance for the transaction up until a certain amount. And the mental model is similar to, when you're sending a package on FedEx and they ask you, hey, would you like to buy insurance on this, right? And you buy insurance up until the asset value. And so similarly, we want to enable like a certain amount of this liquidity to be used in some of these bridge protocols as like insurance mechanisms. And how do we transfer that liquidity from Eigen onto them is something that we're actively working on. Cool. Yeah. We're focused on this journey of bringing cloud to crypto, and we have a lot of different things that we're working on. Some of these things are very much still in design, so open to chatting with anybody who's actively working on some of these problems in the space, and we're very much excited to work with this ecosystem. Thank you so much.
Got it.